Alright, so this is Chapter 7, Section 5, Algebra 1, Semester 2, Lecture 3. This one deals with rational exponents and radicals. And so, certain things that they give us here. We know about the radical symbol. Right, they call this the radicand that's inside the radical symbol. They call this the radical symbol. Then they have this thing here. And that's called the index. So that's the index. This is the radical symbol. That's the radicand. And what the index tells you is how many numbers you have to multiply to get the root, whether it be a square root. So say 25 to the square root like that. This is what we're used to. The index, there's actually a 2 here, but we just don't write the 2. So since that 2, that means that I need to multiply 2 numbers in order to get that square root. We can also have something called a cube root. And in the index we have a 3. And that tells me that I have to multiply this number 3 times in order to get to the root. So in this case, the cube root would be 2 because I multiplied 2 3 times. Here the square root would be 5 because I multiplied it twice, and there's 4, 5, 6, 7, 8. Can be as many numbers as needed for the root. So down here, oh great. What the heck just happened? Apologize for the technical difficulties. Alright. Yeah. So forgot it, number 1. They have letter A. They have the cube root of 27. So I got to think of a number that if I multiply it 3 times will get me to 27. And that is 3. So the cube root is 3. That's going to bother the living crap out of me. Alright, and then B, we have the 5 root of 32. So I gotta think of a number if I multiply it 5 times and get 32, and I believe that's 2. Let me double check. Yep. So 2 times 2 times 2 times 2 times 2. So then the 5th root of 32 is 2. And then we have the cube root of 64. think of a number that when I multiply it 3 times gives me 64. And that is 4 times 4 times 4. So the cube root of 64 is 4. And then D gives me the square root of 36, which is 6 times 6. So the square root of 36 is 6. Alright, radicals and equivalent exponents. So this is going to be dealing with numbers raised to certain fractions. So let's go with the book's example. They have 8 to the 2/3. So the number in the denominator is your index. It's how many times you got to multiply the number to get the root. The 2 in the numerator is your power. It's how many times you're going to multiply that number by itself. So if I was to separate it out, it would be 8 squared times 8 to the 1/3. So remember, 1/3 would be the cube root because 3 is in the denominator, and then the square would be the number that I multiply over and over and over again. So if I was going to write this into radical form, I could write it into radical form in 2 different ways. I can do it as 8 squared and then put it under the radical symbol. That's one way of doing it. Or I can write it as 8 with the cube root, and then in parentheses I can raise that to the square symbol. These two guys are the same. I can either square it and then put it under the radical symbol, or I can cube root it and put it in parentheses and square it. Either way it gets me to the same answer. So I can say that 8 to the 2/3 is equal to the cube root of 8 squared, or I can say it's equal to the cube root of 8 raised to the second power. These guys are equivalent expressions. And these will both be considered radical form as well. So here we have, for got it, number 2a, we have a to the 5/6, and they want it in exponential form. Again, it's going to be a to the 1/6 times a to the 5th power. So then I can do it 2 ways. I usually like to do the power inside the radical, but you can do it either way. Either way is fine. Both of these answers are correct. Got it. B. We have 5x to the 1/3. since the 5x is not in parentheses, the only thing that's raised to the 1/3 power is x. So it's going to be 5, and then 1/3 means I'm dealing with a index of 3 or a cube root. So it's going to be 5 times the cube root of x. Okay, C is a little tricky. We have 54y, and this is in parentheses, to the 2/3. There isn't a perfect cube root for 54. But if I was to divide 54 by 2, and I can say that, gee, I'm going to erase all this. If I was to divide 54 by 2 and say that 54 is equal to 2 times 27. Well, there is a cube root for 27, and that's 3. So I can rename this to 27 times 2y, and then that whole thing is raised to the 2/3 power. So I can do this in a couple of ways. I can say 27. Remember that to the 1/3 means I'm cube rooting it, and then I'm squaring it, times 2y, do the same thing. Okay. 3 is in the denominator, so the index is 3, so I'm cube rooting it, and then I'm raising them both to the power of 2. And then, since I know that cube root of 27 is 3, 3 times 3 times 3 is 27, I can say that this is 3 squared times cube root of 27 squared. I know that 3 squared is 9. Whoops, I don't know what, my brain's not working this morning. Cube root of 2y squared. And I can say that, and make it interchangeable. I can say that 3 half 2y squared. And that will be my final answer. So I divided 54 divided by 2 so that I can get the cube root of 27, which is 9, 3. Then I squared it, which is 3. Then I multiply that times the cube root of 2y squared. It's a little tricky. It's about as complicated these problems are going to get. And then converting things that are in exponential form into, or radical form into exponential form. So there is forgot it 3a. We have the cube root of s squared. So remember the cube root means it's a fraction, so we can say it's s squared times 1 raised to the 1/3 power, and I multiply the exponents and I get s to the 2/3. So that's that one. And then for b, we have 12 times x raised to the 4th to the cube root. So that's 12. And notice that it's not in parentheses with the 12, so we don't have to do anything with the 12. That's x to the 4 raised to the 1/3 power. So that's 12 x to the 4/3. And then c, we have 4y to the 5th square rooted, since there's no number in the index. So that's, oh, this is raised to the 5th power. So we have 4y raised to the 5th power and that's being raised also to the 1/2. So that's 4 to the 5th, y to the 5th, raised to the 1/2 power. Um, 4 to the 5th is 1024, and that's going to be raised to the 1/2 power, and then this is going to be y raised to the 5/2 power because you multiply the exponents, and then the square root of 1024 is 32. So your final answer is going to be 32 y to the 5th over 2. And then lastly, we have d, which is 256 a to the 8th power, and that is rooted to 4, 4th root. Notice that the 256 is not raised to the 8th power. The only thing that's raised to the 8th power is a. So if I was to write this out, it would be 256 times 8, or times a to the 8, and this whole thing is raised to the 1/4 power. So then that's going to be 256 to the 1/4 times a8 also to the 1/4, 256 to the 1/4 power, the number that I multiply 4 times is 4. And then this is going to be a 8 over 4. Well, 8 divided by 4 is 2, so then my final answer is going to be 4a squared. 4a squared. Okay. And that's 7/5. There's only one section that we're doing today. So we are finished. I hope you have a great rest of your